Hi, in this video, I will review how to compute probabilities involving a deck of cards. First, let's review a standard deck of cards. Keep in mind that no jokers are allowed. Thus, there will only be 52 cards in the standard deck. There are 4 suits: diamonds, clubs, hearts, spades, and there's 13 cards for each suit. Furthermore, we have categories of cards. We have the aces. We have the numbered cards. Now, in some examples, they use the ace to represent 1. But for our purposes, we're going to treat the aces as a separate category. So the numbered cards will range from 2 through 10. And then we have the face cards. The face cards are the jack, queen, and king. So that's just a real quick review of a standard deck of cards. Now let's take a look at computing probabilities of these cards. And if you're taking my class, I do have this graphic available for you to access. It should be posted in the current probability module, and it's under sample space for a deck of cards. And you can use that graphic whenever you're performing these types of computations. So let's first look at the example, and then we'll work out the probability. So it says, assume that one card is selected from a standard deck. Compute the following probability. So part A says the card is a queen. So we have to look for all the queens in our deck. It turns out that there's 4. So 1, 2, 3, 4. So the chance of selecting a queen is 4 out of 52 cards. This will reduce to 1 out of 13. The second example is saying, what if we select a card, but now we want it to be an ace or a diamond? When you see the word or, that means addition. But we have to avoid double counting. So we want, first of all, an ace. Well, there's 4 aces. 1, 2, 3, 4. So 4 out of 52 plus, or translates to plus. How many diamonds are there? Well, if we count the diamonds, there's 13. So 13 out of 52. But there's a problem. We're double counting the ace of diamonds. We're counting it with the aces, and we're counting it with the diamonds. So we have to avoid double counting. So make sure you subtract out 1 ace of diamonds, because it's being counted here and here. And when we do that, we end up with 16 out of 52. And that's going to reduce to 4 out of 13. The final example says, if we select a card from a deck, what's the chance that it's a jack and it is black? When you see the word "and," you have to translate that into a card that has both properties. So we need a card that's both jack and a black. Well, it turns out there's 2, right? There's the jack of spades and the jack of clubs. So our probability would be 2 out of 52, which reduces to 1 out of 26. Thanks for watching the video.